everyone. So today we are again here with a new topic, that is derivatives of class 11. Now we all have learned limits in the last video, and so we are continuing the concept of limits now in this one, that is the derivatives. So let us begin without wasting any time the topic derivatives. You all are watching GANITMATICS. I am Michael Dutta. Ab har sawal hoga solve. Now initially, before starting this concept, we have to first learn few basic notations and the basic concept of what actually a derivative is. Okay. Now to explain this concept, let me give you all an example first. Like suppose, for example, we are traveling by a car, for example. Now initially when a car starts, obviously it starts when the time is 0, correct? And after every, if I ask you the speed of the car after every minute, or maybe after every second, or maybe after every hour, then obviously the speed of a car is going to change, isn't it? So that means with respect to time, the speed of a car changes. It cannot maintain a same speed throughout its journey, isn't it? So that means for instance, if I ask you all that what is going to be the speed of the car after 1 hour of traveling, obviously it's going to differ when I'll ask you the speed of the same car after 2 hours. So my point is, if I want to know that what is the rate of change of the speed of that particular car, if I want to know the rate of change, then this concept come into the picture. Okay, so I'm Michael Dutta, you all are watching GANITMATICS. Ab har sawal hoga solve. Okay, those who are new to this channel, you subscribe to the channel so that you don't miss out on any new videos. Right. Now to explain this concept a bit more in a clear way, let me show you all that how we write and from where this derivative concept is coming into the picture. Okay, now let me take an example. Like for example, if I say that I'm taking a function, say the value is twice of x, right? So since we all know what a domain is, what a limit is, then what is the input, what is the output, these things we already know, and we have learned this in our last videos of relations, functions and limits. We have already learned these things before, right? Now for example, say if I take x as 1, so in that case the value of the function will be 2, correct? Similarly, for x equal to 2, the value of the function is going to be 4, right? Then similarly, for x equal to 3, the value of the function is going to be 6. So as you all can see that as I'm changing the value of the x, the value of y is also changing, isn't it? So, but this change, if I want to know that what is the rate of that change, then that is what the concept of derivative is all about, right? So that means with every change in every unit of x, if I get to know that what is the change in every unit of y, so with respect to every input, if I want to know what is the rate of change of the output, then that is what the derivative concept is all about. So let me give you all a notation. So as we know that any value or any output we term as y, right? So that means the change in the value of y, if I denote it as dy, then with respect to every change in value of x, which if I denote as dx, then this dy by dx will be called as the derivative of this function. Okay, so the change of y with respect to the change of x, and this is from where the derivative notation comes into the picture. But this is not the only notation of derivative. There are few more, like for example, we can also write it as d f x by dx, or we can also write it as f dash x, right? So that means the rate of change of y with respect to x is basically what derivative is all about for a particular function. Now also derivative we can also find at a particular point also. That also we will see later. But this is the basic concept. But now how to work out with this situation, how to find the derivative of a function, that we are going to see now. Okay, so now let us take y is equal to fx as a function. Okay. Now suppose if I want to know the derivative of this function, then let's see how to find it. Now for this particular discussion we are going to use the concept of neighborhood also. Neighborhood we have discussed in our limits video. If you all have not seen that, then you can watch from the link that is displaying above. From that link you will get the video of the limits, and in limits you all will get the concept of neighborhood, right? So now for this particular function, right, if I want to know that what is going to be the derivative of this function for a particular point x, then how to find it? So let us understand this concept first. Okay, now for example, suppose I have a point x, okay, and neighborhood basically means that if I'm talking about the neighborhood of this particular point, then we know that we are talking about a small region around that point, and that is a very small region, right? So let me take another point in the neighborhood of this point, and let me name it as x plus h. So that means this much I think is very clear to all of you, that x and x plus h, these 2 points are very close to each other. So basically the distance between these two is so small that it's almost near to 0. Okay. Now if I want to know that for these 2 particular points, what is going to be the change in their outputs? So like if these two are in the domain, so if these two are the inputs, then for these 2 inputs, what is going to be my output? If I want to know what is the change, then that rate of change is derivative we already know. Now let us find that rate. Now as we have just now discussed that these are the 2 points which are very close to each other, so that means obviously the output of the first point f of the point x, it's going to be fx, right? And the output of the point x plus h is going to be f of x plus h. So that means their difference is basically what is the change in the outputs, right? That is going to be the change in y. So if I want to know what is the change in y, then what I am going to do? I am going to do the difference of these two, isn't it? Now divided by, now what is the distance in the x value? What is the difference in the input? That is obviously x plus h minus x, and that is how much then? H, isn't it? So that means the change in the value of y divided by the change in the value of x, if I write it in mathematical form, so this is what we are supposed to get. And since we already know that since these two are so close that it is almost, h is almost near to 0, so that means if I find the limit h tends to 0, f of x plus h minus fx whole divided by h, now that is basically what derivative of this function is all about. And if I want to find the derivative of any function for any particular point, then we are always going to use, or we are going to find the limit of this. Now we all know how to find the limit of a particular function. So using this particular form, we can find the derivative of any function for any particular point. Okay. So this is what derivative is all about, and this is the basic definition, and this is also called as the first principle. So if they tell you to find the derivative of any function using the first principle, then this is what we all are going to do. Okay, now let me take an example and let me explain you all that how we are going to find the derivative of a given function at a particular point. Now suppose if the question is that we have to find the derivative of this function, okay, then we are going to find it in this way. So just now that the form that we have discussed, we are going to use it. So let's see. So then it is going to be limit, so we can also write it as f dash x, that is the notation, we have already discussed this earlier. So f dash x will be limit h tends to 0, f of x plus h minus fx whole divided by h, right? Now let me use this function now. So it will be limit h tends to 0. So if I substitute x plus h in place of x, then how much we should get? We'll get it as per the given function, it will be something like this, right? And minus f of x will be minus x square plus 2 whole divided by h. Pretty clear? So minus 2 and plus 2 will cancel out. So then what we are left with? Let me expand this part. So it will be x square plus 2xh plus h square minus x square whole divided by h. So obviously x square and minus x square will cancel out, right? So it will be limit h tends to 0. Now this is what we have. So if I take the h common outside, so it's 2x plus h whole divided by h. So h and h will cancel out. Now if I place h as 0, if I substitute h as 0, then the value will become twice of x. So that means the derivative of this given function is twice of x. Now this is one type of function. Now if the same question comes, but if they tell you to find the derivative at a particular point, suppose if they tell you to find it at x equal to, say for example 10, for example I'm telling, right? Then either you can first do the derivative and then you can substitute x as 10, so it will be 20, that is also one thing. Or initially here only you can write it as in this form, f dash x. This is when we find at a particular point, then we use this form. So it will be, so you will write it as f dash 10. Then your expression will become, so basically just x will be replaced by this value, rest everything will be the same. So it will be limit h tends to 0, f of 10 plus h minus f of 10 whole divided by h. And in the same way you can substitute and calculate, you will see you are directly going to get the value as 20. So that is how we find the derivative of any particular function with the help of first principle. Now we'll see few standard results that we are directly going to use in our sums. You can also treat them as formulas. Okay, let us first start with the first one. So ddx of c. Now c here basically means constant. So if you differentiate any constant with respect to x, then the result will be 0. And the second one, it says ddx of x. So it will be always 1. Okay. Third one, ddx of x to the power n. That means basically if you have a power, basically if you have a polynomial where you have an exponent, then it will be n into x to the power n minus 1. Coming to the fourth one, so if you differentiate two things in product, one is a constant, c is the constant here, and fx is the function. So it will be same as keeping the constant outside and differentiating the function. Okay. Now these four from 5 to 8, these are basically the algebra of functions with respect to derivatives. So if you differentiate the sum of two functions, it's basically same as differentiating the first one with respect to x plus differentiating the second one with respect to x. Same goes for difference also. Now the product is a bit different. So if you are differentiating two functions, here u and v are two functions in terms of x. Okay. So here basically if you differentiate the product of two functions, then that basically means the first function will be outside, you differentiate the second one, plus the second one will be outside and you differentiate the first one. Okay. And for the division, the one in the denominator will come in front, you differentiate the one that is in the numerator, minus you keep the one that is in numerator outside and differentiate the one that is in the denominator, divided by the square of the function which is in the denominator. Okay, so these are the few basic standard results that you can directly use in sums. Now on the right hand side, you all can see that I have written here 6 more identities like the results that we can directly use. So here if I see the first one, so basically these are for the 6 trigonometric ratios. If you differentiate, then what will happen, that we are going to see here. So if you differentiate sin x, then the result will be cos x. If you differentiate cos x, the result will be minus of sin x. If you differentiate tan x, it will be sec square x. If you differentiate cot x, it will be minus cos x square x. If you differentiate sec x, it will be sec x into tan x. And if you differentiate cosec x, then that will be minus cosec x into cot x. Okay, so these are the 14 standard results that we can directly use in our sums. Okay. Now, since we are, although I have already showed you all one sum, how we can do or how we can find the derivative of a function using the first principle. But what if we face a trigonometric function, then how to do it using the first principle? I'll just show you all one example. Any such sum that you all face, you can do it in the same way. So for example, suppose if I say that a function given here is root of sin x, okay, and if I need to find the derivative of this using the first principle, then how we are going to do it? See, so if I use the concept of the first principle, that is limit h tends to 0, f of x plus h minus f of x
whole divided by h. So what will happen then? Here in the numerator, it will become square root of sine of x plus h minus square root of sine x whole divided by h. But since here the function is in square root, so it will be very difficult for us to find or simplify further or find the limit. So here we are going to use a bit of trick here. So if I want to remove this square root, I'm going to use the concept of rationalization. So basically, I'm going to multiply the numerator with the same thing that I have, but I'll just change the sign so that I can get the I can use the formula of a minus b into a plus b, that is a square minus b square. So I'm going to multiply this with square root of sine of x plus h plus square root of sine x, both to the numerator and denominator, and then let's see what we'll get after that. So here in the numerator, we are getting the formula of a minus b into a plus b, which we already know is a square minus b square. So if we apply square on the first one, then square root will be removed. It will become sine of x plus h minus square of the second one will be sine of x whole divided by whatever we have in the denominator, we'll write it as it is. Now, if you all see in the numerator, then there's basically a formula, isn't it? What formula it is? It is sine of a minus sine of b. So if I use the formula, if I use the identity here, then it will be twice of cos. It's the average of these two. So it's a plus b by 2. So it will become x plus h plus x divided by 2 into sine of a minus b by 2. So it will be x plus h minus x divided by 2. And denominator, we'll keep it as it is. Now, after this, if I see, then we are getting here twice of cos, twice x plus h divided by 2. The second one will be sine of h by 2 whole divided by, now whatever I have in the denominator, I'll keep it as it is. Here I actually committed a mistake. It was plus, isn't it? So these are all plus terms, right? Yeah. So now after this step, so limit h tends to 0. I'll try to form a formula here. We all know the identities limit x tends to 0 sine x by x formula. So I'm going to form that here because sine h by 2 I already have. And this I also have a h here that also I have missed here. One h was also there in the denominator. So that h also I'm going to use right now. Okay. And this 2 which is on the top, I'm going to bring it in the denominator. So it will become h by 2, right? So I got a formula here. And if h tends to 0, we know it very well that h by 2 will also tend to 0. So here in the limit, I'm writing it as h by 2 tends to 0. And rest everything, I'll keep it as it is. Okay. So I'll write it as limit h tends to 0 and rest whatever part that we are left with, we'll write it. X plus h by 2, and then in the denominator I have that entire term, that is sine of x plus h plus square root of sine x. So now this entire part will become 1 using the identity. So then I'm just showing it on the top. I don't have space here on the bottom. So now limit x tends to 0, if I substitute, then in the numerator I'm getting cos of twice of x by 2 because h is becoming 0, and in the denominator we are getting sine of x plus square root of sine of x. Here 2 and 2 is getting cancelled, so we're getting cos x divided by twice of square root of sine x. So this will be our final answer. Okay, so if we have any sum where we have to find the derivative using the first principle, so if there is any trigonometric function also, so we don't need to worry. We have to apply the same concept, but yes, for few particular sums, if you see it's a problematic scenario like in this case, then you have to use some other technique, which you all will get an idea once you see the function, and accordingly from situation to situation, you have to change your techniques. So this is how we can deal with such sums, right? Clear? I hope it's clear to all of you. So now let me show you all 2 more sums which we'll do by using the normal the standard results, and using which, although in class 11 you all don't have too complicated sums of derivatives, very straightforward sums we all have. So let us see few sums based on those concepts. Okay, so let me show you all one example first. These two sums that I'm showing all of you is using standard results we are going to do. Now, not with the help of first principle, now we are doing standard results. Okay, so if they don't mention in exam that you have to do by first principle, then my suggestion will be always do it using standard results, because that will be quick and be fast. Okay, so let's see. So for a particular function, suppose I have the function as, say, I'm just giving one example, is 2x plus 3 into 5x squared minus 7x plus 1. Now, this particular sum can be done in many ways. Okay, I'll tell you one approach. Either we can first multiply and expand it and then separately differentiate, or we can also apply u dot v form here. Okay, so here f dash x will become, so if I consider the first one as u and the second one as v, then I'm going to use that result that we have seen earlier. So it will be 2x plus 3. We are going to differentiate the second one. I'm showing in detail because this is the first sum that I'm going to show you all with the help of standard results. So that's why I'm showing it in detail. And then I'll keep the second one outside and I'll differentiate the first one. Now the first one is 2x plus 3. Now let's see the differentiation here. 5x squared if I differentiate. So basically 5 will be outside, as we know constant comes outside. And x to the power n formula we are going to use here. So this will become twice of x minus. Again a constant, 7 will come outside and ddx of x will be 1. Plus if I differentiate 1, it's a constant, so it will become 0. Now for the second one, 5x squared minus 7x plus 1 is there. Now if I differentiate 2x, then 2 will come outside and ddx of x will become 1. And plus if I differentiate 3, which is a constant, it will be 0. So we are getting 2x plus 3 into, here we are getting 10x minus 7. And here we just need to multiply with the 2. So it will be 10x squared minus 14x plus 2. Here if I multiply, so I'll be getting 20x squared minus 14x plus 30x minus 21 plus 10x squared minus 14x plus 2. Just combine the like terms. So it will be 30x squared. Now here we have 16x. So this will be 2x and minus 21 plus 2. So it will be minus 9. So this is our final answer. So this is how, using the standard results, you all can differentiate. Okay. Simple, I guess. Now let me show you all one trigonometric sum. Suppose the function is x cube sine x. Okay. Again, let us use the UV form. So this time x cube will be outside. We'll differentiate sine x. Okay. So I hope this time you all have understood that this is the u part and this is the v part. You can take it other ways also. You can take the sine x as the first, no problem. Answer will be the same. Plus, so this time sine x will be outside and we'll differentiate the first one. So as we know, ddx of sine x is cos x, so we'll directly write, and here ddx of x cube will be 3x squared. So this is our final answer because we can't further simplify anything. So this is our final answer. So in this way, any sum you can, any particular function, you can find the derivative using the standard results. So I hope after seeing the entire video, the concept of derivative is quite clear, and that is what we all, that is what we have in the syllabus or the curriculum of class 11. Further detailed differentiation we have in class 12, so that we'll see in our another video where we'll discuss about continuity and differentiability of class 12. Okay, so that much for today. Thank you all of you. Those who are new to this channel, do subscribe to the channel. You all are watching Ganitmatics. I'm Michael Dutta. Aapka sawal hoga solve.